Okay, students, welcome to the next session. So, we were doing the method of integration by parts, and it's a special case in which the function is of the type of e raised to power x fx plus f dash x, means the second function is the direct derivative of the first function, right? Now, after having the idea of the method of integration by parts, and there is special cases, now we will move for another method to find out the integral of the other functions. Actually, what happens, likewise derivatives and integration both are very wide branch of mathematics. So, we cannot define only few methods to find out the derivatives of all the functions. Likewise, we cannot define few methods or few formulas to find out the integrals of all kinds of function. So, a number of formulas, a number of methods with their special cases are being defined, are given to find out the integrals of the various kinds of functions. Few methods we have already discussed. Now the remaining we will continue. So among that continuation, or in that continuation, this is also a method which is known as sum standard integrals. So this is what, in this method we have certain formulas, direct formulas, and we can find out the integral of few functions which satisfies the requirement of these formulas, and we can find out the integral of those functions using these formulas very easily. So the formulas runs like this. Some standard formula to determine the different integrals are the formula 1 is this: 1 upon x square minus a square. See, this is what kind? X square minus a square dx. See here, x is a variable, a is any constant, right? So the power of x is 2 and the power of the constant must also 2, and its value is equals to 1 upon twice a of log x minus a divided by x plus a. We enclose it inside this mod. This is known as the modulus function. We will discuss it later. Modulus function means a function which converts all the negative values to the positive. If I write minus 3 as modulus, so it will become to 3. So modulus simply means it's also a function which converts the negative values to the positive one. Okay, that we will discuss when some question of modulus will appear. So the formula is what? 1 upon x square minus a square dx is equals to 1 upon 2a log x minus a upon x plus a plus c. This is formula 1. And this is formula 2. Here we revert a square minus x square. A is a constant, x is a variable. Then we will use this formula. Case 3, 1 upon square root of x square plus a square. I have taken here plus minus both. So the formula works plus minus both. If you are taking 1 upon root x square plus a square dx, its integral will be log x plus root x square plus a square plus c. And if you will take 1 upon root x square minus a square dx, then its formula will be log x plus x square minus a square plus c. And likewise the formula 4th is this. This is somehow a lengthy formula, but we will use it sometimes because we don't have any other way out to write down the integral of certain functions which resembles with these standard formulas. Root x square plus minus a square, this is equals to x root x square plus minus a square by 2, plus minus, if we contains plus here in x square plus a square, so we will take here plus. If we have x square minus a square, then we will take here minus, right? No problem. Plus a square by 2 log x plus root x square plus minus a square plus c constant. Besides these four formulas, we will also encounter some special types of functions like this: dx divided by ax square plus bx plus c. This is also a very special case. If we have given a function of the type of this dx divided by ax square plus bx plus c. So what we will do in this case, ax square plus bx plus c, we will use the technique of making the perfect square here. You all are well versed with the technique of making the perfect squares at your 9th or 10th standard. So we will use the same technique here. Ax square plus bx plus c. It's any quadratic equation. A, b, c are any three constants, right? So we will make this quadratic equation to a perfect square by doing what? By taking a as common. If you take a common, what is left? X square plus b upon ax plus c upon a, right? No problem. Now this b upon a, it should be multiplied by 2 and divided by 2. So what you will get here? It will become b upon 2a into 2x, right? See, a is x square plus b upon 2a into 2x. What we did? We multiplying and dividing the middle term by 2 plus c upon a, right? And what is the rule of making the perfect square? This b upon 2a should be squared. You will get b square upon 4a square. So this number should be added and subtracted in the given equation, and see what happens. A x square plus 2bx upon 2a plus c upon a plus b square upon 4a square and minus b square upon 4a square, right? What we did? We are adding and subtracting this square in the given equation. So see, a will remain as it is. What we are getting? X square plus 2bx upon 2a plus b square upon 4a square, this plus c upon a minus b square upon 4a square, this, right? So this is what? This is x plus b upon 2a square. This is the square of this. If you will use the formula of a plus b square, so x plus b upon 2a square will equals to x square plus 2bx upon 2a into b square upon, and this is what? C upon a minus b square upon 4a square, right? So this is a square of, take this as t. So what you will get here? See, this is t square, and take this portion as a, you will get here k square. So this equation, which is in quadratic form, has been transformed to this form, and this is very much similar to the any one of these 2 or 3 formulas. So this is how we will convert to a quadratic equation whenever needed to a perfect square by using this technique, right? Let us see in the example how it will work. Say, evaluate this. Evaluate dx upon x square minus 25. So dx upon x square minus 25. See, we will use very simple case. X square minus 25 means 5 square. So what is the formula? This is the formula of x square minus a square. That is dx divided by x square minus 5 square. Right? So this can be written as like this, and the formula is what? 1 upon 2a, yani 2 into 5 log x minus 5 upon x plus 5 plus a constant. So we will get this, and finally 2 into 5 is 10, 1 upon 10 log x minus 5 divided by x plus 5, right? Now take this. This is formula 2. Here the constant is before. So 4 minus x square. See, this can be written as 2 square minus x square, right? So this is 2 square minus x square. Again use the formula. These formulas you will have to remember. And finally you will get this as answer. I have nothing to do in this. I can't do anything. We are directly using the formula. This is case 3. X square plus 36 under square root. So this can be written as x square plus 6 square and under square root. And you know the formula of this is what? Log x plus root x square plus 6 square plus c, and finally you will get this. And finally the fourth is x square plus 64. It means root x square minus 64 means 8 square. Right? X is a variable, here this is a constant. So this can be written as root dx divided by root x square minus 8 square. So this is equals to log x plus root x square minus 8 square, that is equivalent to log x plus root x square minus 64. So these are the examples which are directly based on these formulas. But the situation is not always like this. So we will take another example. Look at this. What we have discussed of making the perfect square. You will understand it from these two examples, right? So what is given here? See, we have given here dx divided by x square minus 3x plus 1, right? So x square minus 3x plus 1, this is a quadratic equation, and I have just told you whenever we are having a quadratic equation in denominator, we will make its perfect square, or we will convert it to a perfect square. And the process of converting the perfect square I have just explained, and I will explain it again in this example. See what we are having here. We are having here x square minus 3x plus 1, right? What we did there, we have taken the function was ax square plus bx plus c. What we did here, we have taken a common, but here a is 1. So no need to take 1 common, 1 is 1. So we have taken 1 common, then but here a is 1, so we will not take anything in common. See, this can be written as x square minus 3 divide by 2 and multiply by 2, right? We will divide the middle term of the quadratic equation must be divided and multiplied by 2 plus 1, right? So what we are getting here, after multiplying and dividing, we are getting 3 by 2, a new term, right? 3 by 2, square of 3 by 2 is 9 by 4. So what we will do, we will add and subtract 9 by 4 in the given equation. See what happens. X square minus 6x by 2 plus 1 plus 9 upon 4 minus 9 upon 4, right? See, x square minus 6x by 2 plus 9 upon 4, this one, and what is left here, plus 1 minus 9 upon 4, right? See this portion, this is what, x minus 3 by 2 power 2. See, x square plus 9 upon 4 minus 2 into x into 3 by 2, so 6x. So we are getting the same thing. So this is what? This is x minus 3 by 2 whole square, and what is left here? 1 minus 9 upon 4. What you will get? 1 minus 9 upon 4, that is minus 5 upon 4. This is minus 5 upon 4. Now make it the perfect square. It is almost done. X minus 3 by 2 square minus, how you can do it here? Root 5 upon 2 square. Now we have converted to this quadratic equation into the known formulas which we have just discussed by using the technique of the perfect square. So see what we did. This is this line. So this quadratic equation has been converted to this form by using the concept of the perfect squares. Actually, we have converted this quadratic equation to the perfect square. X minus 3 by 2 square minus root 5 upon 2 square. This is what? This is the formula of x square minus a square. And you know the integral of such kind of function. So see how we will write down its solution finally. This was our given function. This can be written as dx divided by x minus 3 by 2 square minus root 5 upon 2 square, and the formula of this is what? 1 upon 2a. 1 upon 2a. A is what? Here a is root 5 upon 2. So 1 upon 2 into root 5 upon 2. 2 and 2 will be cancels out. Log x plus 3 by 2. Log x minus a upon x plus a. So here x is x minus 3 by 2 minus a is root 5 upon 2. This is your numerator. x minus 3 by 2 plus root 5 upon 2. This is your denominator. So 2 and 2 will cancel out. What is left? 1 upon root 5 log. Simplify it. Open this bracket. You will get here 2x minus 3 minus root 5 in numerator and 2x minus 3 plus root 5 in denominator, right? So this is how you can proceed whenever a quadratic equation is given in denominator. You can convert it to a perfect square by using this technique, and then you can integrate it. Conversion of a perfect square means take the middle term of the quadratic equation, multiply and divide it by 2, and then what gets square of that number. See, once again, what was the case? The case was like this: x square, see, x square minus 3x. See, case was x square minus 3x plus 1, right? So x square minus 3 divide it by 2 and multiply it by 2 plus 1. So what is left here? 3 by 2. Square of this, that is 9 upon 4 should be added and 9 upon 4 should be subtracted in the given equation, and then it will convert to the perfect square. Likewise, take this example also. You can also see this one. Integrate the function x square minus 1 divided by x4 plus x square plus 1, right? See, x square minus 1, x square minus 1 divided by x4 plus x square plus 1, and this is integral sign. This is equals to what? If we take x square common in numerator, what we will get here? 1 upon 1 plus 1 minus x square, and take here x square common, what will left? X square plus 1 upon x square, right? This is tx. This will cancel out and this is your integral. What we will get? See, this step is clear. We are taking x square common from numerator and denominator to get this step. Now, after having this step, what we are having? We are having 1 minus 1 upon x square divided by x square plus 1 upon x square plus 1 dx, right? Now, we will integrate this function, and we can integrate this function by only guess, our intuition. We don't have any specific method. So I think we are having 1 minus x square in numerator. So we should use the method of substitution is the best way out. We may have other options also. What I feel this would be very comfortable for you people. So we will use the method of substitution to find out its integral. See, what we will substitute. If we take t is equals to x plus 1 upon x, right? If we take t is equals to x plus 1 upon x, right? So if t is equals to x plus 1 upon x, then square both sides. You will get here t square, and square of this is x square plus 1 upon x square plus 2 into x into 1 upon x. So you will get here 2, right? What we are having here? We are having here x square plus 1 upon x square plus 1. So change it. If we do it, t square minus 1 can be written as x square plus 1 upon x square plus, subtract 1 from both sides, t square minus 1, here 2 minus 1, you will get here 1. So this is what? X square plus 1 upon x square plus 1, it is x square upon 1 plus x square plus 1, this is equals to t minus 1. Be careful, right? We have taken t as x plus 1 upon x, then the value of t square minus 1 is your complete denominator. What is left? 1 minus 1 upon x square dx. So see, it's very simple. T is x plus 1 upon x. What is the value of dt over dx? 1 minus derivative of 1 upon x is minus 1 upon x square, right? So what is the value of dt? dt is equals to 1 upon x is 1 minus 1 upon x square of dx. Now think carefully. What we are having here? we have taken as t is equals to x plus 1 upon x. This is what we have substituted in this function. And you know what happens in substitution? In substitution, a variable given in the question is being replaced by a new variable, right? Here in the given question, our variable is x. So what we are doing, we are taking t is equals to x plus 1 upon x. So in substitution, the variable x will change to the new variable t. Clear? This is what we want to do. So t we have taken x plus 1 upon x. So what is the value of 1 upon x square into dx? This one. 1 upon x square into dx. See, 1 upon 1 minus 1 upon x square dx is coming out to be dt. So the value of the shaded portion is dt. And x square plus 1 upon x square plus 1, see from here, x square plus 1 upon x square plus 1 is coming out to be t square minus 1. Okay. So what we will change and how the integral will be substituted? See, 1 minus 1 upon x square dx is equals to dt. So in numerator, in place of 1 minus 1 upon x square, are you getting the point? Try to understand it. In numerator, 1 minus 1 upon x square, its value is coming out to be dt, right? So we will substitute dt in place of numerator. And what we are having in denominator? In denominator, we are having x square plus 1 upon x square. And you know the value of x square plus 1 upon x square is t square minus 1, right? So in place of x square plus 1 upon x square plus 1, we can write down t square minus 1. So what we get? We are getting this t dt upon t square minus 1. So our given integral 1 minus 1 upon x square divided by x square plus 1 upon x square dx has been substituted or transformed to a new function, that is this dt divided by t square minus 1. And you know t square minus 1 means here t is a variable and 1 is a constant. We know the formula of dx divided by x square minus a square. Here a is 1, right? The formula will be what? 1 upon 2a. A is 1, so we will get here 1 upon 2. Log t minus 1 upon t plus 1. We cannot leave our answer in terms of t because the question is given in terms of x. So our answer should also be given in terms of x. So substitute the value of t. So 1 upon 2 log t minus 1 upon t plus 1 plus a constant. Put the value of t, what we have taken as t. T is equals to x plus 1 upon x. So see, we have substituted the value of t here in this function. 1 upon 2 log t, x plus 1 upon x minus 1 in numerator and x plus 1 upon x plus 1 in denominator. Now you can simplify it. 1 upon 2, what you will get here? X plus 1 upon x, you will get here x square plus 1 minus x in numerator. So this is your x square plus x square minus x plus 1 in numerator and x square plus x plus 1 in denominator plus a constant. So this is the integral of the given constant. Actually, what is the main objective? The main objective of this method is what? This is all the part of the method of integration by parts, right? In fact, we are using the method of integration by parts in special cases in various forms. So these are the cases in which we can directly use these formulas what we discuss. We can find out the integral of the various kinds of functions using the method of using the formulas or using the standard formulas, right? Even then, still there are certain functions which cannot be integrated by using all those methods. So students, we have discussed almost 3, 4 or 5 methods to find out the integrals of the various kinds of functions. As a brief, they are: case 1, we can find out the integral of the various function using these known formulas. Two, we can use the method of substitution by making substitution of a variable to a new variable. Then we have used a specific case in the form of the substitution method, that is, whenever a function is of the type of numerator upon denominator, and numerator is the direct derivative of denominator. And then we have used the formula when two functions are being multiplied, then how we can find out its integral, that is known as the integration by parts. And then some special cases, e raised to the power x fx plus f dash x dx. And then finally we have evaluated few integrals by using the known integral formulas directly, and solve some examples, and I tried my best to make the things you clear. So I think I should stop the lecture here, students, and continue the subsequent text in the next lecture. Thank you very much.